Hi, everyone. I'm Kevin DeYoung. I'm a senior specialist solutions architect with our front-end and mobile services. So that covers Amplify, AppSync, and Device Farm. Today, we're going to talk a little bit about AppSync and some of the stuff we do with real-time in the AppSync service and solution. Just to kind of get an idea of the room, to show of hands, how many people are using AppSync today or interested in using it? A couple. Okay, perfect. What we're going to do is just do a quick kind of overview of AppSync, its capabilities, its features, and then we're going to dive into some real-time scenarios. I have a chat use case for that scenario, and then we'll also do a demo on that capability. And kind of talk a little bit about the evolution of what we can do with real-time. There's some new capabilities that were just released, so we'll also talk about those and some features there and how to leverage those to enhance that experience. So AppSync, for those that don't know, is a managed GraphQL service. With that service, right, we get simplified data access to backend services or RESTful APIs, microservices, and we can correlate, bring that data together in a single API call. So one of the examples we talk about a lot in this scenario is like a blog system, right, where we have you have an author posts, comments on those posts. And we can kind of aggregate those in together and show all that data together, right? So we get information from the author system, the posts, and the comments, and bring that back in a singular API call, even though there might be many microservices or different data sources on the back end. That's one of those good benefits of GraphQL in that case. Improve app performance. So the other thing that we get with this, right, is we can pick and choose the type of data we want to return based on maybe the format of the screen or what is visible. Mobile device doesn't have screen state as a front-end app, right, or a desktop app. And so we can choose to limit what we're getting, and then that impacts on the back-end systems, right? So by selecting and choosing those things, when we do the queries, we are changing how the system acts and gets data from the back-end. And then real-time experience, right? So we provide a managed WebSocket connection service with AppSync that allows you to communicate with clients and customers in a real-time fashion using those WebSocket connections. So kind of give you a basic kind of overview slide of what this looks like, right? So on the left, we have our customers and clients. We have abilities to do offline as well with AppSync, right? Using things like DataStore or caching and doing the syncing operations with AppSync. And then we have our supported data sources on the right out of the box. We support DynamoDB, Aurora, OpenSearch. And then kind of a catch-all with Lambda, right? Once I get into Lambda, I can pretty much do or query whatever I can with Lambda, right, in that scenario. We also support HTTP resolvers if you have to communicate with microservices that are RESTful APIs. So we have some customers that will kind of surmise a bunch of microservice RESTful APIs into a single GraphQL instance and then use that from their app. And then local. So this is a non-data backed source. This gives us a way to communicate or do real-time data sharing, but not actually store the data in a back-end system. So it's a way to just kind of share that data as it happens. What's not really shown here is kind of as a T line up on the right goes through, it's a system called resolvers, right? And we're providing that compute logic for your resolvers to operate. And if you write your resolvers in VTL, right, we are doing that processing on the AppSync service side. So simplified data access. So kind of going through this example again that I was talking about before. In this system, right, we're talking about a retail system, right? And we can pull this data now in from disparate resources in a singular API call and bring that back to the customer. So we have our profile information stored in DynamoDB, right? We're getting our pricing information from Aurora, right? And that backend complexity is kind of taken away from our front-end developers or even the user or the consumer that might be using these APIs. They just have to make this single query. We kind of do all that querying, correlating for them on their behalf, and then we send them the result as a single response. The other kind of little benefit here that we won't talk about too much today, right, is we can do some caching on the per resolvers, right? So if our inventory system or our pricing system doesn't change that much, or maybe is a little slower than some of the other systems, we can actually cache some of those results as well, speeding up what those queries will do or the response times to our customers.
So this is data aggregation, right? Not data aggregation, not orchestration.
It's data aggregation. There is a level of kind of orchestration that kind of happens, right? Like we have to understand how to query the other data source, what's relational to the parent, right? To make sure that we're querying the right data. So there's a kind of a level of, if you will, orchestration capabilities in there, but it's mostly just to aggregate and get that data correlating to the parent record, right? So like when I query orders, I have to know who I'm querying for, right? Yep. And sorry, this is a chalk talk, so I'm kind of open to questions, and I should have repeated that. So the question was, sorry, going back, was, is this orchestration or, you know, or data aggregation? And it is a level of orchestration and aggregation, right? We need to understand how these things relate, how to query the different data sources based on how that relationships work. I can actually show that a little bit later, what that looks like from the AppSync side, and how we do that with resolvers and per field resolvers and things like that. So real-time scenarios, right? So there's a bunch of scenarios that kind of fall into this space. There's probably many more that I don't even have described here, right? But a few that we have out there that we know customers are using, right, is dashboarding for real-time or IoT data, right? IoT is continuously updating things. We want to see those things from our mobile devices, dashboards, different things like that, right? So we can use real-time data in those scenarios. The chat application, which I'm going to show today, at least a little version of one. Stock prices, a couple things I couldn't find logos for that we have customers doing. Sports scoring, right? Real-time sports scoring on your mobile devices. So we can keep those things up to date as they happen and as they occur. So those are a few of the big examples there. So I'm going to talk about a chat application, right? So if you've kind of paid attention to this, we have a few blogs out there on AWS on how to do the chat, right? And they work, but there's been some evolutions in the service itself that have kind of evolved what we can do and do some things better. So I'm going to use this example a little bit more extensively and kind of evolve those original blog posts, if you will. So in this example, we're going to end up with 4 different data types that exist, right? So we have a user, right? Just the information about the user. Who are they? Their username, that type of thing. And conversations, right? So people are enrolled in conversations. Conversations can have many users, so we end up with a many-to-many table in the conversation user table. Just a way for us to relate that many-to-many relationship. And then we have messages, right? So messages belong to a conversation and they're written by a user. There's a lot more fields that go on behind this that you'll see in the later slides, but for the most part, this is the main things that we're worried about, right? For maintaining a chat application. So in this one, right, so if we think about the GraphQL thing for the people that are, maybe not as familiar with this, right, we have the idea of mutations. So mutations are what's changing the data on the backend system, right? So on the left, we have this idea of a create a message. And to do that message, we need the content of the message and the conversation that it belongs to, right? And then you'll see on the below that, right, are the fields we're returning when this is successful. So these are the fields we want to return back to the customer and the client in that scenario. Right, again, this is that pick and choose area, right? If you don't care about all those things, you don't have to pick them all. It's just all of, they're all available to you to pick. And then on the left-hand or the right-hand side, sorry, we have queries. So the idea with the queries, right, these are the read list capabilities. So we have list messages, right? And then we have list conversations. So we can see the different conversations out there and that type of thing. What I wanted to show a little bit on the conversation side here is we can actually go down and look at the users, right? So now our conversation can see the users that are part of a conversation, right? While that's a separate data type, we're pulling that into that conversation response. So we get that as a singular API call. These are chalk talks too, by the way, so feel free to ask questions as I go if you have any. All questions welcome. All right, so that's kind of how those look like. Just wanted to show you kind of what that looks like on the back end. There's more queries and mutations, but these are kind of the ones that are worth noting and just gives you an example of how these kind of look. Worth also taking note, right? If I leave out the users option on that right-hand list conversations, I'm not querying that data type, right? I'm not querying that backend system. So again, right, when I say it kind of optimizes for the scenario, if I have a mobile device, I can just list conversations maybe without having to understand the users behind it at this page. That's fine, right? We can do that, and we don't have to worry about that system being queried in the backend. So it's optimizing based on the payload it's returning. So one of the goals, right, of a good chat app is message privacy, right? We don't want people to see other messages from other conversations. So there's a few big things from that that we want to call out. The CRUD operations, right? So the basics, right? If I'm reading or I'm doing a list messages, right? We want those to be responded back with the conversations that a user is part of, right? Right now we can do that. We have VTLs, we have Lambda functions we can do, right? We have ways to limit that, build a query to DynamoDB based on the conversations that somebody's a part of. There's a lot of options in that regard as far as what we can do to handle that scenario. So that's always kind of been there. The next part, though, is the real-time updating stuff, right? Like, how do we make sure that when somebody subscribes to our WebSocket connections, they're not getting messages from other conversations that are occurring, right? And that's the area I'm going to kind of focus on a little bit and talk a little bit about what those capabilities have been and what they are now. So message privacy, right? So this slide, a little animation. So for those that don't know, right, subscriptions work on mutations. So subscriptions, right, are those WebSocket connections that we have, right? They will send data over those WebSocket connections when a mutation occurs. So subscription, in a way, is just a watching of those mutations as they occur and sending that message out. So in this state, right, we're looking to on create message as a subscription, and it's looking for that create message mutation. In this case, right, I'm not providing any parameters, so there's no filtering involved here. The result of this, though, is that everybody can see everybody's message over that WebSocket connection. And so there's really no privacy in this point, right? Everybody's getting everything. You can see everything if you know where to look. Then there was basic filtering, right? The second bullet point, no way to drop a user connection, that should be crossed through at this point because there is a way to do that. And we'll talk about how to do that. But it used to be that you couldn't do that. It was once you were subscribed, you couldn't cancel a subscription. It was just always set permanently at that point until the customer resubscribed. But at this point, right, what we're doing is providing a parameter. So in this case, we're looking at conversation ID. This is an equals operator. So this means that I can, if a mutation happens on create message with that conversation ID that I subscribe to, I will get that message. The good part about this is I can provide a Lambda to validate that I'm part of a conversation, right? So now I'm getting some level of validation that I'm allowed to subscribe to that conversation's messages. But like I said, if I were to be kicked from that room, I can't cancel that subscription or anything like that, right? It has to, there just sits there in perpetuity until the customer reconnects. The other drawback of this is each conversation is a new subscription. Because I can only do an equals filter, I have to, if I'm part of 5 rooms, I need to subscribe 5 times. I need to just kind of keep repeating this, right? And now I'm managing this in my code. Especially if I want to have like a little thing on the side that says, there's 2 messages here, or new messages alerts, that type of thing, right? I need to do that subscription many times for the number of rooms I'm in. Not very scalable, right? You can do it, but there's some even limits on that, right? I can do 100 subscriptions is kind of the limit right now. So you have to kind of, your limit would be 100 conversations you could be a part of or filter on. So really recently, I think within around a month ago, right around that time, we enabled some new features. The first one, right, is advanced client filtering. So now we have this capability of providing a filter from the client side. Let's get that go. And that filter gets passed in, and then it can process, right? But we can do some of the same processing, right? I can still run a Lambda to validate that you're providing me a filter that says these are the conversations I'm a part of, and I can validate you're actually part of them. Right, that type of thing, right? So there's just some capabilities here, but the client in this side is deciding that advanced filter and passing it in. We're processing that filter, validating it for validity, and then enabling it, if you will. So now one subscription can now support multiple conversations, right? So I don't have all the filtering capabilities here, but there's an equals, there's an in, there's a not equals, less than, greater than, right? So there's a basic set of normal filters you would expect available to you, right? And I'll show a little bit more of the logic of this because there's some and or capabilities in this as well. And I have that at a later screen. So the next one is advanced server filtering, right? So not only can the client specify it, but now I can also do it on the server side. So now in this standpoint, right, I can do onCreate message again, like my original example. But actually I can just set the filtering on the server side, which means now I know that you're only getting the messages that you are subscribed, or the room messages to the conversations you are allowed to see, right? But I'm deciding how to implement that. It makes it a little easier on the customer not to have to worry about those things or building that filter themselves correctly, those types of things, right? So it looks fairly similar on how those filter language or the syntax works. It just changes who implements it, right? The client or the server. But the filtering syntax and all that stuff is exactly the same from the last example. So again, right, one subscription can support multiple conversations. So what does the filter look like? This is kind of the basic structure, right? So you'll see on the top there is our $extension set subscription filter. That's a function called a set a filter on the subscription. It's something that has to be put into your resolvers response area to specify that. So you have a filter group, and then you have filters. And I tried to draw just a basic example here, right? We're just going to search for field name, conversation ID, operator equal, value room 1, right? And then that will make sure that that filtering is only sending messages that pass that, right? If I want to add some and logic, I can do that under the filter section. And then you can see I can do a whole new filter group, and that's more of an or type action. So you can kind of build these filters and do a lot of things in these areas, right, as needed. Again, right, equals, in, contains are all options on the operator side. For this one, we'll just be using equals. So the other thing I want to call out, right, is canceling a subscription. So like I said, right, on the one slide, it's changed a little bit on whether or not we can cancel something that is already existing or a connection that's already existed. That was hard to do before. So this new feature that was just released allows us to do that. And this is a two-sided process. So it's good to understand how this two-sided process kind of works. So on the subscription side, what we're doing is set a subscription and validation filter, right? So this looks a little bit like my other filter, but it's different. So again, look at the extensions, right? We're setting a subscription and validation filter. The logic of the filter groups and the filters work exactly the same. And the same types of operators are available. But in this case, I'm just going to look for username, and then I'm going to use for the value. And for this, I'm just taking the value out of the call itself. So in this demo, I'm using Cognito. So it's just my Cognito username, basically, that I'm using in this standpoint to do the filtering. So that's just right out of the context of the call. On the mutation side, right? So what we're going to do is as a mutation is done, right, and we're changing what conversations I'm a part of, I am going to try to run an invalidation against, or attempt to see if any of those subscriptions need to be invalidated, right? So again, $extensions, invalidate subscription. The subscription field is the subscription on the left-hand side, right, on create message, and then the payload, right? So the payload is the username, which associates to my field name, and then the value. Right, is just the context ID again, right? So I'm passing in, like here, I'm the user that's leaving this room, and then it's passing that on to filter through the create messages subscription to see which connection should be removed, or completed, I should say. Any questions on that so far? No? All right. All right, let's, I'm gonna flip to the demo if I could. All right, cool. So everybody able to read that, or do I need to zoom in? Zoom a little bit? All right. Let's see here. That better? I can go a little bit, but I'm afraid my screen's gonna get all weird. All right. So this is kind of the schema that was created. I'm going to show actually another way. So the way I did this, right, is I ended up using Amplify to generate this code and to make it a little quicker for me to kind of put something into place. So one of the reasons why I want to show it this way is Amplify kind of does a lot of help for me in creating a lot of things inside the schema, a lot of the VTLs, the resolver templates, right, based on my schema. And so I kind of just started with this just to kind of speed up the example, right? So in this, right, I have that conversation type, I have the message type, and I have a conversation user. Actually cheated a little bit on the user side. I just used the cognito information for the user information, so I don't need that user type in this scenario. And then you can see I have set all the auth rules. I can say who has access to do what items. So I can set some level of security on my actual types. Do some indexing for DynamoDB query reasons, right, and those types of things. So all that's kind of specified inside this schema. Why I show it that way is when it gets blown out here, there's a lot more there here than was in the Amplify side, right? So Amplify is going to enable things like the DataStore for doing offline syncing. If I want to do offline capabilities, it's going to help me create a bunch of mutations and queries that I don't have to worry about creating, right? So I'm just going to use Amplify to help generate those resources. So now you can kind of see what this blown out conversation looks like. So the question earlier, right? So here's that users, right? Conversation has users. When we see that, right, we have this on the right, the conversation. And you can see now we have this resolver on that users field, right? So this is a way for us to resolve that users thing from another data source and aggregate that result in here. So if we look at that pipeline, I won't show it all. There's not too much to it. You can kind of see this pipeline of resolvers. And then that query that we're building to query DynamoDB is here. There's a bunch of logic here to do that. But you get the kind of the idea, right? We're resolving that and processing that as part of that type. Conversation user exists as well. And then I want to go down to our queries and mutations so we can kind of see what those look like as well. All right, so now you can kind of see what these look like, right, that are generated. We have get conversations, list, sync. All these things are kind of auto-generated right from the Amplify side that we use. And then our subscriptions, right? So we have subscriptions on pretty much all of the different mutations that exist. So we can subscribe to those things as needed. This helps keep our data store intact and do some other additional things that we want to do. So let's go to, I want to kind of show this a little bit in 2 steps. I'm going to do a query. So at this point, you'll notice that I am logged in with Cognito into this query page in AppSync. And I'm going to just pick some items in this on create message just so I can subscribe to it. And you can see now that it's running on the right-hand side, right? So I'll subscribe to one mutation, looking for messages basically at this point. What I'm going to do next is sign into this app. Nobody tease me for my designer sense. That's not my specialty. So it's a pretty basic app, right? Nav bar, or kind of a nav bar on the top, right? Conversations on the left, and then messages are kind of in this window in the middle. There's no messages right now, but I did create a few conversations to kind of kickstart the demo. And then I'm going to log in as a different user here. I'm going to log in as that same user here, and there's a reason why I want to show this kind of together a little bit. Okay. So now I'm going to go to the workshop room on both these, right? So I'm going to show some messages on the bottom just because it helps kind of understand what's going on the back-end side. So that's why the developer screen's there. I probably should have. Yeah. I'm going to zoom in just a little bit because I don't need all that real estate anyways. So what we're going to do is just send a message in here. Right, and what we're getting back on this side, right, is real time, right? So this subscription, as that message was sent, right, that WebSocket connection is taking that message and getting that message and displaying it on my other side, right? So in the way this side, I'm doing DataStore, so it's which still uses subscriptions, but it just helps make the client code a little easier for me to write and use. But the result is the same, right? I'm getting that message over my WebSocket connection, and I am processing that appropriately on my page. If you look at kind of what this looks like, right? So here's my WebSocket connection. This is getting really small, so I apologize. But you can actually see these messages come through, and you can see, here's the payload. Here's what it looks like, right, as those messages are coming through that WebSocket connection, right? So here, again, right, this is all kind of data on create message, right? We've seen that at this point. Here's all the data for that on create message, right? So that's what those messages look like as they come through that WebSocket connection. And so I should go back and forth. So as you can imagine, right, back and forth, right? Real-time chat in a way, right? So we were able to send these things there as those mutations are happening. All of our customers are keeping up to date on what's going on. The other thing I want to show is what it looks like from when you do a cancellation, right? What does it look like once we leave a room, and how do we handle that inside of our code? So there's a few things I'm going to do here on this side. So what I'm going to do is if we look at our Amplify allows you to override resolvers that are auto-generated. So what I've actually done is overrode some of the aspects of that chain of pipeline of resolvers and put on certain things that happen here. So what we want to do is, as we remove ourselves from a conversation, we want to remove, run that invalidate subscription call. Looks very similar to the one I had on the screen, right? It's just passing in the username from the context of the person calling, and then we're going to invalidate their subscriptions to on create message. So we're kind of overriding this and providing this in that mutation cycle. And then I should show this side too. What I actually did to build the filters. So here you can see the subscription invalidation filter, right? So I actually added this into a phase of the Amplify side on the pre-subscribe. And now I have this invalidation filter based on the same criteria, username, right? So this is deployed into my pipeline resolvers, which are used on these subscriptions and mutations. So now on this side, when I do a leave, you'll see on the left-hand side, right, that removed itself from over there. But the other thing that happens, right, is I get a complete message pass through. So what this looks like from the WebSocket connection side, if I am good enough to find the message here, is, there it is, right? So we just did a complete. What gets passed back is, right, a WebSocket complete data payload. And so what we've done is just completed that WebSocket connection from the server itself, right? So now the client had that WebSocket connection completed. We have to obviously reestablish that, rebuild our filters as necessary, those types of things that have to occur there as that message is completed. The other screen kind of to show this, right, is we have a subscription complete here, right? So we got that message back from the server that said this WebSocket connection subscription is complete. Obviously, I can reestablish it now at this point. What I've actually done in this code is resync up what happens on that side. So if you look at some of my code, what we've actually done, right, is specify this complete It just calls a function. So here's my subscription, right? Looking at this WebSocket connection. I'm using the DataStore behind the end. This is more of like a monitoring mechanism I'm using on this page at least. But we're looking for the complete message, right? And we're processing a function as a result. And what we're doing on that is just, I'm going to clear the DataStore just a little bit on how DataStores work right now, and something that's being worked on. But I have to kind of reestablish the WebSocket connections with the DataStore to keep my page up to date. And then I kind of want to do a redraw of the items in there. So what happens still in this standpoint, right, is I'm able to still communicate with the customer. Different conversations are continuing to occur, because in my app, I'm now handling that completion. I'm resubscribing, reconnecting those subscriptions, and letting the server rebuild my filters so that I can continue to use my app as I would normally use. So that's kind of how this gets broken down a little bit. Any questions on that part so far?
So if the subscription is to mutation events,
yes,
is that only going to pick up on data changes that are coming through the GraphQL?
Correct.
So if there's backend data changes, is there a way to float that up?
Yeah, so there's a few mechanisms that customers use. There's a few examples of why this ends up happening this way too, but one of the ones is, right, you can have the backend systems just run their mutation against AppSync, right? And then they're just updating it there and letting it trickle down the right way, right? The other thing that we've seen people do is end up using that local PubSub model to send out just those changes from the backend system. There's still mutations, but they don't have to get saved in the backend data store, right? They're just there and available for people to do. What you have to worry about there, though, is like as I maybe log in, right, I have old messages, right? It's only going to give me the as they occur, and then there's no history after that. So you have to figure out how you might sync up anything for history's sake. But once they're connected, right, that local PubSub model happens, and you can do it that way. So some customers, even from like asynchronous systems, will do something similar, right? If you're calling out to like maybe run a quick site report or something that has a little bit more processing that has to happen on the back end, what we'll send back as a response is maybe like a unique ID, and then you can subscribe to a channel on that unique ID. And then once that backend system processes it, builds a report, we can send that mutation local PubSub out to let them know, hey, this report's ready for you to pull down, that type of thing. Does that make sense? Yeah. So, and I did a horrible job of repeating the question again. I apologize. So I'll do it now again. The question was, subscriptions, are they only for mutations? The answer is yes. There's some ways to get around, like I said, just not having to have a mutation actually modify data in the back end. You just use the local it's called no data when you look at it from the AppSync side. But the idea there is that there's a no data source, not BS, right, in this one, that we use that it doesn't have to have any data actually manipulated in the back, right? So I can have customers subscribe to it and get real-time updates, even though no data is actually being modified on the backside.
So the models that you generated in DynamoDB,
yep,
they will be creating separate tables, right?
Correct.
So if you do want to use an existing table, which we try to use like a
Yeah.
single table design structure with custom partition keys and sort keys,
Yep.
what would be the approach?
So good question. So the question is so in my example, right, I had Amplify actually create a bunch of DynamoDB tables. What if I already have existing DynamoDB tables? Or what if I'm doing, maybe the single table type design or architecture for my DynamoDB tables? What do I need to do in that standpoint? The answer is it's all in your VTL. Or your Lambda function. So you have two ways that you can kind of resolve this. It's more of a level of comfort and what you're comfortable coding with, right? So the velocity template language, if we go back and look at our VTLs, I'm just going to show them, right? So, wait, I'm going to do the ones that were built. So if we look at like a query list messages, I think this will help you understand where we're basically building all of this to be processed. There's our list request. This one isn't the greatest example, unfortunately. Let me try the get one, see if it's any better. The end of it is we're basically building what you would imagine is a DynamoDB query, right, in our VTLs. So you can build that however you see fit, right? If you're using partition keys or like concatenation of keys from the payload, right, you can build those things and do those queries as you need. It's all going to be on how that query ends up being built and then executed on. So here, actually, what's probably better to show, DynamoDB, AppSync queries. Let's see if we can do this. So here's all the DynamoDB kind of things we can do. You'll see that this really closely relates to the normal calls that occur. And so you can see like, hey, we can build this to do a get item and a key and a consistent read, right? So you can build this thing to be whatever you want, right, with VTLs. So there's some examples we have. We actually have a couple labs that we actually create immersion day contents that actually use a single table design and talk about how to structure that VTL in a way that makes sense. And so you can absolutely do it. The other thing, if you're really comfortable more in like a JavaScript or a Lambda language, right, just use a direct resolver to Lambda, build your query in there, run it, execute it, and send back the results. Depends on just your comfort level with VTL.
And does that work with Amplify?
It does, from the standpoint that you would have to override all this stuff. So the question was, does it work with Amplify? You can do a few things on the Amplify side. You can import existing tables into your Amplify side, right? And then you can also, like I said, and I did in my example, is all these generated things I can override and provide additional things for. It's not there natively, right? It will help a little bit, but you're gonna have to kind of build it out a little bit on your own too. So I guess that's your question. Yeah, you're gonna have to do a little bit more building that way, right? And figuring that stuff out. Yeah.
Do you have any information on speed results for certain resolvers? We use pretty much every one of them. I just was curious if there's any benefits to any one over the other.
For between like a Lambda or the VTL or what?
Well, like you mentioned like a Lambda direct resolver or DynamoDB. We use all of them, but I was just curious if one's faster than the other.
I don't. So the question is there a speed difference between the VTL and the Lambda? I don't know. I mean, there might be some part with Lambda and start times and things like that that might equate to it. Probably depends on your query frequency and whether or not you have enough instances running. I don't have any general guidance on it though. The VTL stuff, right, is going to happen right on our servers and our instances as they're running, right? So it's going to be it should probably be a little quicker, but I don't think it should be horrible difference. Any other questions or thoughts? Because I will start talking about more. How many people are using real-time data in their AppSync instance? One? Anybody interested in real-time data? A few more. What? Out of curiosity, what are you looking at doing with your real-time data? If you don't mind sharing. Okay, transaction data. You? Something similar? Yeah, okay. Yeah, it's a great use case for that. We have some really big customers doing some stuff in that regard, right? And showing some stuff there. If you look at our references, there's some big scaling there. We've scaled out tested the scaling of those WebSocket connections. You can get up to 10 million WebSocket connections, right? So plenty of capabilities in that regard as far as what you can do and build out.
Default quota is 1,000 transactions per second. Does that apply to WebSockets too?
That does. There's a different quota for that. There isn't really a quota per se on the number. There's a quota, I think, on how many per second can subscribe, right? But it's just more of a scaling type of thing to make sure we can scale up as we kind of go through that. Yeah. But I haven't heard many people running into limits with with the WebSocket connections and those types of capabilities.
I'm sorry, one more.
Yeah.
Is there caching on the WebSocket side too?
The question was, is there caching on the WebSocket side? No. Yeah. So it just sends it out and that type of thing. I'm going to just talk through a little bit more as we go. If anybody has any questions or thoughts on things they're trying to do in this space, I will gladly take them. Just to give you an idea, we're using a lot of pipeline resolvers in this side, right? So pipeline resolvers allow us to kind of query or stage together different functions that exist and stitch them together into a response. So if we look at this pipeline resolver for list messages, right? And this is, again, some of those things that are built with Amplify. But I would suggest kind of following a similar pattern, because I can reuse some of these things across my different functions, especially if they're similar, right? So what we kind of Amplify does, right, is it adds some additional logic for auth and authorization of the records, right? Maybe there's an owner field in there or a group field in there, and you want to make sure that this person has access to modify a record or get that record based on, you know, their membership into groups, that type of thing. In our case, right, we might want to limit their messages on list messages based on what conversations they're a part of. So we have some steps in here on the pipeline resolver side for functions of auth, and then we also do some stuff on the resolver side, right? This is the actual query that we're running, but we're doing this. You'll actually kind of notice, because of a recent version of Amplify, that this doesn't really match. It's query get conversations auth. It's because they're deduping the resolvers to make sure that we're keeping them, you know, the payload and the size of the templates we create smaller. So again, right, we're just reusing this same you know, function multiple times across many pipeline resolvers. So that's why that's listed like that. These all transform into functions. So you can see I have a lot of functions now created. These functions are tied to the data sources, right? So now I also have this capability in my pipelines to query different data sources if I need to. Maybe my example of a group is different from where like the messages table, right? So I have to go to conversations, figure out what, or conversation user, right? Figure out what conversations a person's a part of, and then query messages with that conversation filter set, right? With a pipeline resolver, I have functions that hit both those data sources, but in the end, right, a function's tied to a data source, whether it's non or a table or whatever, or a lambda, right? All those are kind of specified in here in our function side. The caching, we support full request caching per resolver caching. So in the per resolver side, there's a lot of configuration and query or things you could do in here, right? You can invalidate cache. You can set the keys that are used for the cache. If you don't set any, we kind of just try to do our best guess on it. But you have some configuration on how those items are cached. That's available. One of the things I really like a lot of is the logging and then the X-ray integrations, right? So as you are building a application, right, that might be pulling in from many different data sources, different things that are going on, right? There's a lot of backend queries. Good to have some ability to monitor that, see what the transaction times are like to your different data sources, that type of thing. That's something that X-ray can help with and show you. So I enable the logging a lot because I have to troubleshoot my awesome code. You'll show the integration in with Cognito. On this one, I used Amplify to build Cognito, associate it, and set the authentication on here. Just to give you an idea of the other things that are supported for AppSync authorization and authentication. We also support IAM directly, API key. API key kind of ends up being public, if you will, for those that are in the Amplify world. IAM directly, and then you can also do a custom authorizer. So we have a lot of customers that have their own authentication authorization systems, right? You can still use a custom Lambda authorizer to validate somebody for the request. Let's see, we got about 15. Let's see here. The other thing I want to call out a little bit, anybody doing or interested in offline capabilities for their application? Anybody using that? Yeah, okay. What are you using today? Are you doing anything today?
Right now we're using DataStore for syncing like some of the user information.
Okay.
Between different devices for like whenever they're signing into an account.
Yeah, okay, cool. Anybody else? Okay, yeah, you are? Okay.
Same thing, the data store.
DataStore. Okay, cool. There's a few ways to do caching. DataStore is obviously one of those ways with Amplify. So what's good from this, right? When I write my code, what I like to, the big benefit I get from this, right, is I don't have to worry about if you're offline or online, right? The data store is actually keeping and collecting this information and keeping it locally cached for me to use, right? It's dealing with the sync operations to make sure the data's in sync as it gets synced up, right? It's setting up the subscriptions for the real-time data updating and keeping that that data store up to date as your device may come in and out of service. So there's a lot of really interesting capabilities in this. So one of our big use cases in this is, it's like an offline or like a field tech type of role, right? So a field tech might be out working in certain locations. They may not always have great service, but they're working with a work order system or a different thing, right? They want to be able to update that record as they're working on something, right? And they can do that with DataStore. And even if they're offline, and then when they come back online, right, we're going to resync that data from the DataStore back up against AppSync, basically in the end, right? And then when we do that, there's multiple ways in which we can keep that in sync. There's different resolvers, how we determine if a record's been mutated, how we want to merge that record, and you can even back into a Lambda type thing to merge those records into, so you can provide additional logic if you even need. But what I love about this, right, is this capability that I don't have to worry about whether or not I'm offline or online, right? I'm just working with the data store, and the data store is doing our work for us and keeping it up to date. So this is kind of what this looks like. We're querying our message model from the data store. Because I set some things to be questionable, I had to provide alternative results. I can still sort in the data store. I can still put in filters in the data store and return certain things based on my use cases. What's also nice, right, is, again, looking back through this, and then I do the create message. So where's that create message code? There we go. So then in this case, right, this is what it looks like working with the data store. I'm actually just doing a save. This is a new one. It kind of works the same if you're doing an update, but what you can actually do is if you have the existing record, right, you can kind of just do some cool React stuff of merging those models together and those objects together and then just do a save. So there's even easier ways to kind of do an update. But again, right, I'm just doing a save in the data store. The data store is taking care of doing the mutation on the back end, right? That's getting processed through the subscription back into the next client over. Kind of some of the other things that get created with that, right, is the models. The models serve the data store, and then the GraphQL language queries for the API layer. So I wanted to show that off too. What are you writing your apps in when you use the data store? Are you all front end? iOS? Okay. Are you using a cross-platform type language or using native Swift? How about you? Flutter? Okay. And the data store is working pretty well for both of you? And
Yeah, we're getting it to trying to get it.
Okay. You can talk to me afterwards. I'll see if I can help you with that. Okay. Cool. So yeah, so the data store too on the Amplify side, right, is supported across many different platforms and languages that we support. Amplify has libraries for, React, Angular, Native, Flutter, Swift, Kotlin, right? There's a lot of different libraries that exist for Amplify. Those data store capabilities come along with all those different language options that exist out there. All right. Yeah.
For the mobile application, what all files get deployed on the device, and how about all the keys, secret keys, and how to secure all this?
So it depends on how you do it. There's a few ways, right? So the Amplify libraries, right, are kind of, they may in a way live above the SDKs, right? They're just instantiations of those things to work with our AWS services easier. So if you're doing something with something like Cognito, right, we provide authentication mechanisms for Cognito so that you can integrate it and build those calls to AppSync with the right, SigV4 signatures, all that stuff that we would need to validate who the user is. Does that make sense? So in that standpoint, nothing really. There is an idea, like I said, when we looked at the AppSync page, there was that API key. So there's also this idea of kind of public access if you have the API key. So you could also distribute an app with the API key, and then it's just going to use the API key to authorize, right? I wouldn't consider it really a secret at that point. It's just there, but it helps kind of, make sure whoever's querying it at least has maybe an app or some way of knowing that secret was, or that API key was. Does that make sense? Okay. The question there too was what gets deployed to the application for, or to the iOS device for keys when you're doing authentication and authorization. And it kind of depends on the app setup and the authentication authorization mechanism you pick. But in a way, right, we're trying to work with things like Cognito or other types of providers to kind of make that, that there's nothing really there from on the iOS device itself. Obviously, you're going to need to install our libraries, and those will be compiled into whatever you compile into and send to the, to the customer. So if you look at our Amplify libraries, right, on the React page, right, we're doing a Webpack down of those JavaScript things, but it's just, a very tight set of code there. Yeah. Yeah.
Can I look at AppSync as I want to do a faster development, but later I want to move, calling the API from my application?
Yeah, so the question is can I see AppSync as a way to help speed up my mobile development, right? In a way. I would put Amplify into that category, right? As a way to speed up, developing and putting together your mobile applications. I don't know if you'd want to go away from calling it, but if you have use cases or wanted to use RESTful, you can still do that. You just kind of have to build it. Some of these features I talk about are only kind of with like AppSync, right? Like offline, real-time data, right? Exist, as capabilities of AppSync. So if you don't need those, you could just query the RESTful APIs directly if you wanted to. What I would probably suggest is just figure out, like I said, like AppSync can call RESTful APIs, right? So now I'm just creating that singular API endpoint that maybe calls my microservices on the back end and aggregates that data for my customers and clients. The other thing that people like, right, is that AppSync schema supports some level of introspection, right? So when I look at these models and GraphQL items on this page, these are all kind of like auto-generated from the schema itself, right? So by being able to see that AppSync schema, I can do some, auto code generation, so I can work with that schema a little easier, right, from a front-end development space. All right, any other questions? All right, cool. Thank you, everyone. I will be hanging out here for a few minutes if anybody wants to come up and ask any other questions. So, thank you.